So, straight out the block, may the force be with you, yeah, on May the 4th. Anyway, so welcome to the round table. We're going to talk about data centres and their development in the future, edge data centres, what's driving the edge, whether it be inner or outer, I'm not sure. We'll talk about that, hyperscale, and we'll look at the impact on what the future demands from data centres means in terms of the design, both internal and external, maybe even locations as well, energy cost, etc., etc. So we've got four basic parts we're going to talk about. New technologies that are driving the change. What does this actually mean for the data centre? How are the two of those interactive parts, the edge and the hyperscale, and what will come in between, if anything? I think something will come in between, but we don't know what yet exactly. Then the impact having on the design requirements for the components in the data centre, probably centering around power, but we should also mention cooling as far as location is probably concerned as we go through. So, kicking off, let's talk about the new technologies that are driving data centre design. Is that technologies or is that applications? Geraint?
More applications, drive the technologies. I think the biggest change we see at the moment is a lot of discussion about Internet of Things, 5G, smart cities, but to me those are all coming. The stage we're at the moment, the next 3 or 4 years, is re-architecting the current networks and data centres to prepare for that. So the activity we're seeing at the moment is what telcos would call CORD, central re-architecting of telecom sites into data centres, and then of the edge build-out by all sorts of companies, content and telecom, in order to prepare to roll out the new applications which we all talk about, like the Internet of Things and smart cities. So it's 4 years of preparation before the new applications.
You don't think we're already there?
No.
Oh, that's interesting. Mikhail, have you got an opinion on that?
No, I don't think we are there either. I think it's still, at least we have to wait until 2022 before we reach the 5G build-out and come closer to the edge.
Common misunderstanding is that the edge means the network edge. It doesn't, it means the content edge. So it's all about where do you roll application, computer processing and storage to, and the edge of the boundary of the computing and how close to the subscriber or the user that is. And when you're looking at the network hierarchy, you have to choose where you wish your content edge to be, and the content edge may be at a different location than the network edge. And one of the big debates we have every week with customers is, is the content edge going to go right out to the network edge, and what is the edge of the network, or is it actually going to be an inner edge, an outer edge? The inner edge is where the content services many applications. The outer edge tends to be much more application specific. So, for example, in a town or a city, you will have an edge of where the content goes to. But once you get into particular applications like digital television, in each village, each suburb, each street, there'll be an outer edge where that application applies. But if you're not delivering digital television to that street, then you won't have that outer edge. But you'll still have an inner edge where all the content from the web and the streaming is stored. So it's about where the computing and storage goes, not where the network goes. But as each generation of ICT has rolled out the last 40 years, for financial reasons as much as anything, you always start with content at the centre that is long-lined out to the user over whatever infrastructure you've got. And then there comes a point when the sheer volume of traffic increases, so you have to put some intermediate controls in. And what we're seeing now is, the edge is control of content and storage of content near the edge, and the cord, as the telcos call it, is really the intermediate layer. So as the traffic builds up, you cannot long haul all that traffic and give good latency, good performance, or the users switch off. So you have to start putting in an intermediate layer and then an edge layer. And then ultimately, to your point, you'll end up having an outer edge where you have a street side cabinet, or you'll have a single rack doing computing in a hotel room, for example. That'll come, but there's a gradual build up of a pyramid structure and a rollout of layers. And what we're seeing at the moment for the next 4 years is, all over the world actually, is designs and plans to roll out the intermediate and the edge layers And without that, there isn't a belief that Internet of Things and 5G will work effectively, because there's too much traffic being long hauled from handsets, smartphones, all the way back to data centers, which again, as you said, could be in any country, wherever they are. So there's a need to roll out these intermediate infrastructure in preparation.
Given the current, yes, you certainly can.
I think also, I mean, the 5G build-out and the new applications that we will work with in that network, that will require a lot of low latency data centers for self-driving cars, for instance. I mean, you can't work with that and having a long latency. So I guess the new applications that is coming will also define the new edge, and that's why we say that this will start 2022 when the 5G rollout will begin.
Yeah, I hope that automatic guided cars, self-driving cars, I hope that they're not controlled by the edge. I hope they're controlled by GPS on board the car. But because the type of hardware that people are rolling out is not our traditional ultra reliable, resilient. So you're driving down the street, if the local lamppost, which has got your local edge in it, outer edge, fails, you don't want the car just to go straight on, do you? You want it to stop.
But I think also, I mean, how you build up these new networks, I mean, they are talking about self-healing networks. So I mean, for redundancy and for safety, they will look different.
So you hope that the next lamppost is close enough. Yeah, exactly. So, but to Garen's point, what do you think about the fact that, well, if I said to you, I'm not sure this is true actually, but let's test you out on it. If I said to you that the edge will be rolled out only by telcos?
No, I don't think so, and that's actually one big debate that we have. Who will own the edge? And the telcos could be someone, but also maybe someone else. So we see some rapid changes in the market around the data centers, and maybe, I mean, colocation operators today will change in also to owning some parts of the edge. So this is still an open question.
Yeah, and you've got telcos, and you've got tower companies in many parts of the world may take over that. The colos will convert and adapt to be edge in particular towns and cities. So that's the core transition going on at the moment. And then you've got the threat that the content providers themselves will get frustrated with the speed of that. It's too slow for them. And so the content providers will roll out their own edge in competition and just wholesale the bandwidth. So when we're rolling out a new infrastructure like an edge, we have to make a choice with the customers as to what sort of applications they're rolling out, because that determines the type of data centers, the type of cord, the type of edge, inner or outer, that they'll need. So it is very application driven, which means that customers have to think through their business cases, where they're going to make their money to drive their investments, and not do it just because everybody else is doing it. Do it because your applications make you money.
I see that's an interesting point. If you think of the edge, especially what you call the outer edge, the decision at that point will be made as to whether the communication that it's carrying out can be batch processed or not.
Yes.
So we'll go back 40 years to batch processing again, so we can say, well, we'll do that and report it later when the network's not so busy.
Yeah, how is the storage architected? You know, is it in batches? Is it uploaded, downloaded? Is it real time? What size of batches are required? Is a very important part of IT design now, and that's changed.
So the question is, what's going to kick off that exponential growth again? And that could be the Internet of Things and the smart everything.
I think it could. And you asked about the size, and I can see that we have discussions today with customers talking about the edge in terms of something that could be half a rack, maybe 5 kilowatts, and then going up to maybe a couple of hundreds kilowatts. So depending on the application and where it is in the world, that will differ. And if it's inside a city or outside a urban area, so that's yeah.
Yeah, the half a rack is what it's in my mind. Yeah. The half a rack, 5 kilowatts, maybe even liquid cooled, which we'll come on to maybe later. But yeah, it's an interesting point.
I think we see a very different buying behaviour and then end result in the enterprise and service provider markets. So in the enterprise market, we see people trying to guess what capacity they'll need for the next 5 years. And then, as you said, they often overguess, and then they realise they don't need quite so much. And the IT guys are always working on efficiency, and the efficiency and the amount used comes down, and then they have space left. Whereas in the service provider community, it's very much a pay-as-you-grow. So they start with a minimum amount. They use modular architectures and they grow. And if anything, we've seen them underestimate the scale of growth in the last decade around the world. So what we actually see in the service provider communities is accelerating growth and the need to get more capacity all the time.
If we look specifically at the two extremes, the edge and the hyperscale, maybe what's coming in the middle, how's that going to actually impact the data center as we know it today?
Well, I mean, if we look back, I can see, based on my own experience, that somewhere around 2013, the mid-sized data centers started to decline, which meant that a lot of enterprises that were mid-size went into colocation instead. And just before that, we also started to have the discussion around cloud, and cloud was meant to be, or a lot of people thought that was the answer to everything. Which wasn't true, of course.
But no one really understood at that time that cloud is just someone else's data center.
Exactly. So now we have these giant data centers, and we have the colocation data centers, which is also quite big. And then we have smaller companies having their own premises, of course. So with all these new technologies and these new applications that we are developing for Internet of Things and self-driving cars, there is a need for something in between, and that will be the edge data centers. And this year has actually been named by some organization that this will be the rise of edge data center.
Yeah, we have to remember the role of Delta and ElTech. It is not to choose which business cases are successful. It's for our customers to do that. Our role is to facilitate for them the ability to exploit their business case and deliver it, and to do it in an optimal way, and to give them our best experience and our advice of what works, what type of solution infrastructure applies if that's their business case. So they're going for the high performance, hyperscale, blockchain type world, or if they're going for the mainstream market, IoT, 5G, here's the type of infrastructure you need. And our role is to deliver for both. It's not for us to decide who's successful or not. We will help our customers achieve their business.
You should never go horse racing and bet on just on the favourite. No, absolutely. Each way bets.
I have also seen customers getting more data for each year, but still.
Some do, yeah.
Some do, and again, I mean, there is not, one solution for everyone. So it's about being ready for the future and being able to adapt to it.
We make technology extremely modular now. We make it extremely scalable. We try to make sure that the same architecture is deployed for the smaller site as deployed for the biggest. And that's not been done historically. You move from one technology to another, so that if it succeeds, you can have as much of it as you need. And if it doesn't succeed, your upfront investment is quite small. And that's a cultural thing, but that moves into our design thinking, our engineering, and then we have to alter our factories to produce technology according to those principles. So that's the fundamental change going on at the moment. We're re-architecting our factories globally to produce technology that you can have a small amount of or a vast amount of in a consistent way globally, depending on how successful you are at defining your own business case.
Hedging your bets.
Hedging your bets for the customer, not telling them what's right.
So, Mikael, one point I'd like you to clarify for me, the idea that Geraint gave of the chain, the flow of the chain from the hyperscale all the way down to the inner and outer edge, if you want to describe those two things separately. Do you think there's any pieces of that chain that will disappear? Some people, you hear them talk about it'll just be the edge and the hyperscale.
Yeah. I think we will have there will be a hybrid, of course. No one, or very few, can use only one of these. So a hybrid will, for a foreseeable future, be one option. At the same time, the industry and the market is trying to get more and more efficient. So the ones that can get better efficiency will also be the ones that grow in the future. So I think the hyperscale will still be very important. So what will happen with the other one down below there, I'm not really sure.
No.
But in hybrid for sure.
We've certainly seen both experiences. So massive number of telecom customers and then also the big hyperscale customers. And so there's a content community that thinks you grow the hyperscale and you feed an edge and you get rid of the intermediate levels. But there's a telecom community that has a hierarchy of levels that thinks it's better to upgrade that and do a period.
And owns the network.
And owns the network.
So the interesting thing that you didn't mention was the fact that you need a network for the hybrid. You need a hybrid network. Yeah. You need some of the network that can push content down below, and you need some of the network that can say, no, I'll just have high-speed communication back to the hyperscale. So we're talking about hybrid networks as well as hybrid data centers and hybrid customers and hybrid edge. And
I think the biggest impact that there is that we have a decade of massive change going. We're going to have another explosion of change this next decade. There's demand all over the world from all sorts of companies to do all sorts of things. No one quite knows who's going to succeed, other than there will be change and there'll be huge growth. There'll be winners, there'll be losers. So what it does mean for us, though, is that we have to simplify the transition process. So we spend our time looking at exactly what technology is required. Are there intermediate layers you can strip out? How do you make things easier to manufacture? How do you deliver all over the world? How do you support, install and maintain reliably all over the world? Yes, so we're going to go a decade of digital revolution. It's well underway and we have to facilitate that as best we can. And that's what our focus is. And the scale of the change, shouldn't be underestimated. We're already in a situation where there's exponential growth, there's capacity shortages. It's the 80s since we had global shortages in components and capacity, but that's the new world because everybody is trying to transition at the same time. And we have a fundamentally step change, a digital revolution, if you like, in the next 10 years, and there'll be winners and losers through that. So we spend our time trying to make sure all the applications are serviced. We make the manufacturing as simple as we can. We take out in the intermediate layers, we make it as modular and scalable as we can. And we supply it to any geography, be it 3 kilowatts or 300 megawatts. It's the same approach all over the world. And that's what's required to deliver the scale of transition. We've had to double our factory output capacity, ready for it, and we'll probably have to double it again. We have to globalize and we have to increase our local presence because, the reasons you mentioned previously about serviceability, working with the independent marketplace as well as our own people to give, because the scale of deployment required for all these applications, Internet of Things, 5G, cord, edge, is vast. And it's barely begun, and that's the biggest issue for the industry. How do you scale up on such a vast scale in every country to all these wide range of applications in the space of 10 years?
So does that impact in the sort of design equipment that you're thinking of? Let's think of power, just power, AC or DC power. Do you think in the future it's going to have to be more reliable because there's going to be many, many more smaller installations? Does the equipment itself has to be more reliable, self-healing, self-diagnostic?
Already today, where we go with a solution, we always take the very site into consideration. So the country, or where we're going, and how are the customer going to be able to maintain that afterwards. So that's part of the design process, actually.
We do see a change though, because in the enterprise colocation data centers where traditional IT is supported, Tech Power, we supply AC-based power solutions. But for the reasons you just mentioned, in the industrialized applications which we're involved in now, hyperscale, blockchain, telecoms, internet, we're using direct current, DC power. And people often make me smile when they say there's no direct current out there. We've supplied 1,000 megawatts of direct current power in the last 2 years. But the rollout has been of lower voltage, 48 volt computing has been the big change. So it's
AC to the rack and then DC racks?
Yes, or it's DC and DC, but certainly those are the two options. And currently AC through the distribution and then DC to the compute is the big change. But the point about that is it's looking for ways to simplify and the technology and the manufacturing to enable a big rollout to many locations. So all the industrialized applications, the smart cities, the utility stuff, and the blockchain and the hyperscale is simplifying back to direct current. And there's a massive rollout, silent revolution, I call it, going on in those sort of applications.
It's pretty silent because no one else has heard of it.
Exactly, yeah. And those guys, and for those guys, they don't, you know, it's in their commercial interest to do the rollout and then tell people afterwards. So it is going on, it's at a massive scale. So we're seeing the simplification of the technologies going on to in order a massive scaling up of the amount of the technology. And you know, we deal with the consequence of all those things. You know, it's not we do our best, but it's not for us to control business cases or relative wealth and how countries organize themselves. But the sum effect of the growth factors exceeds the efficiency gains that you rightly pointed out, because we see the capacity required we have to manufacture going up exponentially.
Mm.
Yeah.
Yeah, that's the problem. I think that we get the end of the argument. We don't get involved in the first part of the argument. So people get told we're going to have a 5 kilowatt rack, but we at the data center end never get involved in the discussion of what that 5 kilowatts actually doing. We just assume that's the you know, the holy cow. That's the elephant in the room. That's what we mustn't ever criticise. That's why PUE was invented, to take the focus off of the one. As we transition from this non-edge reality to the edge future, do you really think that latency is going to become an issue? Or has the increase in capacity of fibre and even copper gone up to the stage now where latency will never be a problem?
I think latency will be a problem for some applications. I think we came to a point for a lot of the things that we're using every day where it's good enough, at least in some parts of the world. But for some applications it will be a problem, and one of the challenges is that we don't really know today what we will have tomorrow. So there is a constant development, and it's going quite rapid. So yeah.
Capacity is the problem already. So it's not.
Well, it's because we're using capacity is a problem at the moment because we're still using up the stuff we installed in the early 2000s. There was the dark fibre that was there that was never used. It's almost deteriorating now. But you know, when you look at cabling today, you can have 1 gigabit per second, 10, 40, 100, and there's usually a constant upgrade path from 1 to 100. So it's 100 times the speed of fibre, of speeds which you could never dream about. Do you remember the old 64K modem?
Yeah.
64K modem, you know, with a little beepy sound when it dialed up. We're light years, literally light years ahead of that with optical fibre. But it's an interesting point.
The distance for these solutions, I mean, you can't go faster than light. So,
no, apparently.
No. So latency will be a problem for some applications.
Yeah, we've established that there's going to be a hybrid future of inner edge, outer edge, middle facilities, all driven by content. Yeah, more so, and then latency. So content and latency has always been an issue and always will be an issue. We've probably agreed that there'll be lots of different size power solutions as you go up the chain, as you called it, from the outer edge all the way up to hyperscale. So the question is, in that chain, how are we going to see data centers built and constructed? Now, when I say data centers, I mean everything from, one cabinet, which is a data center if it's got power, cooling, and compute and storage in it. All the way up to hyperscale. So Michael, how do you see what are the important issues for future data centers?
I think most of the customers that we speak with, I mean, what they need is to have a solution that they can rely on today, but also grow with in the future. So a modular approach for any kind of data center is desired. However, I mean, you also have to make the frame and decide where you want to go. But we use the modular approach in most of the discussions that we have today.
Mm. Oh, I see that too. I mean, people not wanting to spend all the capex up front and put it off till when the customers arrive. I also see a lot of people finding out that they're designing for certain cabinet densities, and then the customers don't arrive, and they can actually use some of that infrastructure for the next phase.
Yes.
One of the other things we've done is we've stripped the power products down to match the IT products more closely. So what that actually means, we have a family of inverters and rectifiers that do the different voltages the new applications require, because there's quite a wide variety of voltages used. And you are more on a one-to-one ratio with the servers and the switches on the IT side. So we have a minimal kilowatt unit, and then we can scale that up to megawatts, and tens of megawatts, and even hundreds of megawatts. So that's what we mean by modular. Then the issue then is how you divide the systems up and the control between them. So we work with customers on that. But it means we can match the density of the power and the cooling solution to the density of the IT, to the density of the application at each location. But the manufacturing process, the delivery process, the support and the maintenance process is simplified and consistent in all locations. And that's what makes it easy. It's all about making it easy for our customers to deliver their infrastructure and look after it.
You've mentioned the idea of the flexibility, and that obviously is a great help for customers who are capex constrained. They don't want to spend all their money at once. What about the speed of deployment? Do you think that people make decisions later, which means they have to have delivery faster, or?
So that's a little bit different, or different customers have different needs, and for some customers speed is very important. So that's also why we are working with the traditional approach, with a traditional brick and mortar solutions, but we're also working with prefabricated data centers. So that could be everything from a small one with everything in one box, so to say, or a large data center that could be several thousand square meters, made by
modules.
Yeah. And that the prefabricated approach actually can cut up to like 50% of the project plan out if you compare prefab and traditional ones, because you can build the foundation at the same time as you make the house with all the installations. So when speed is a need, prefab is one of the answers. But we also have other options where we supply like power modules or cooling modules to customers that build like large colocation centers.
Plant rooms.
Yeah.
Yeah. Do you find when you do the modular data room layout that the customers would prefer you to do all the foundations in one go to avoid vibration later?
So normally, what I've seen, we do the foundation for the complete facility at the first step, but then we only build the part of the data center that they need today in order to don't have those vibrations and maybe impacts.
Do you think that one of the solutions will win over the other, or will we always end up with both bricks and mortar and modular construction?
If you have time and you're in a place where you have a good supply of material and labor, I think it will be more economic to build it in a traditional way.
Yeah.
But in some places, cheaper, yeah. But in some places it's hard to find labor, and it's also hard to find material. And then the prefab is the better one. So there will be a hybrid there as well. We will use both of them, and as I said before, we also have combinations of traditional buildings in combination with prefabricated parts of it for
plant room, generators,
UPS, the switchboard.
Yeah, I think both will carry on for foreseeable future. Two reasons. One is customers have existing assets, so a lot of them have property which they wish to enhance and upgrade. So, and secondly, that every site is different. So you have, sites are hard to find. Suitable sites are really hard to find. So you have to adapt to your site conditions. And sometimes the best way to adapt is prefabricated. In other locations, it's a hybrid. In other locations, it's bricks and mortar. So we make sure we can deal with whichever's required and is most appropriate to that site.
What's going to happen with the edge as far as reliability is concerned? Are we still going to look at the edge as being a data center that needs precision power and nearly precision cooling? I
think so. As far as I can see today, I mean, we will still use UPSs, some kind of cooling, there will be redundancy and so on. So I don't think we will reduce that.
I think all the applications, the quality is going up. You know, because we as users expect higher quality video. We notice it, the expectations are higher all the time, not lower. So I think the pressure to keep the quality and reliability up will only accelerate, which means we're forced to readdress those same issues of, you know, how's the power backed up, how's the cooling reliable, you know, how's the IT fall over or transfer, you know, all those sort of issues will continue.
And in your business, do you think this fast rollout of integrated systems, which contain UPS and other things, do you think you'll offer solutions, complete package solutions for these deployments, or are you still looking to sell it to the people who roll out the solutions?
We offer complete solutions. So, I mean, today we offer complete solutions that includes everything except the servers, you can say. So everything from the transformator all the way into the PDU and the server rack, and the same thing for cooling and.
Well, if you offer a solution, it's usually the client. Most users, when offered a solution, either want it because it's cheaper. But they're going to give you the whole job, so they want it cheaper, or they want one throat to choke, as they say. They want to put all their risk into one person that they can then grab hold of. So, for example, a disadvantage for most companies is if they're too big. If the company is too big, it means they can pay when they get sued. So,
I think most of the customers that I speak with today, they want one partner, one to discuss with, and if something goes wrong, I mean, it's only...
And that does push you then to offering a solution, because the more you can bundle together.
Yes. So I see that as a clear trend.
Yeah, we see it as I suppose it is a management of risk. It's a collaboration with really the service providers to offer a complete package and also to manage the transition from where they are now. So it's actually a program that has to be managed as well as a solution. So it's solutions with programs for the service providers. We additionally have a reseller division that works with integrators. You mentioned that separately for enterprises. So the integrators will have their own solution for the enterprises, but Mike and I work with the service providers directly on the managed program transition, including the solutions required, but also the project management, delivery, the support, because our clients are, focus on a 15-year horizon, and not just a 5-year horizon. Maybe for the next change, it's all the changes that are required for the next generation.
Yeah, I mean, timescales are certainly getting shorter, aren't they? And payback periods of even 5 years are now regarded as unviable, but it's a crazy situation. So the industry is very slow to change. Do you think that this revolution, as you call it, that we're kicking off, this will change the conservative nature of the industry, or will we still be slow to respond?
Part of our role, as solution consultants, if you like, is to understand the differences. So the differences are already there. So we have to understand. So a colocation client has a different perspective on those issues than does a telecom client, or a cloud provider, or a blockchain, or a hyperscale. And we already service all those types of clients. So part of our role is to understand the preferences of each of those, and then we alter the solutions to reflect those requirements. It's already fact today. I could go through each of them and take you through the difference in their approach. And some are extremely traditional, and right through to others which are extremely experimental. And we have all types, and we deal with all sorts.
And I think on the cooling side, I mean, the temperatures there all connects back to ASHRAE and the warranty from the different manufacturers of hardware. So as long as they don't change that, I mean, I don't think we'll see a rapid change of...
So cooling temperatures, from 18C through to 33. Battery life from 8 hours or through to nothing at all are examples of that. The
point about ASHRAE, of course, is that They've expanded the envelope over since 2004. They've expanded the envelope a lot. They've done a lot for the industry. They've changed the point of where you measure the temperature and humidity from the crack return to the inlet of the server. But they are the server manufacturers. Yes. They're not an independent body. They write standards, that's true, ANSI standards, American national standards, but they are dominated and successfully dominated by the server manufacturers. So you're quite right, you know, the ability to get away from that envelope, you do it at your own risk. Yes. Definitely do it at your own risk, because you stay within it.
But because, you know, the industry is getting older now, and there's more experience in more countries. So, you know, one of the changes, whether you follow ASHRAE as a leading American interest group, or you don't follow ASHRAE, is one of the discussions that we would regularly have now.
Okay, well, I think we've looked over the entire data center industry this morning. I think the three of us agree that there's no one solution that fits all. Mm-hmm. And there's lots of business models out there that need individual specialization, and we'll have parts of the market that go extremely risk dominated, and parts of the market which will stay completely risk averse. Correct. And the one that will win will be the one that survives.
Correct. Exactly.
Okay, thanks very much indeed for your time.
Thank you.
Thank you.